Hi, I'm Chelsea, and today I'm going to demonstrate how to go about multiplying matrices. Now, unlike adding and subtracting matrices, multiplying is a little harder and requires a little more analysis. So to begin, let's look at just my quick example where I'm multiplying a matrix A and a matrix B. In this case, I did choose both matrices to just be small 2 by 2 matrices. And we're multiplying A and B together. Now what's important, and in order to determine if you can in fact multiply two matrices, is whether or not the columns of the first matrix is equal to the rows of the second matrix. So these two values need to be equal. And then, if they are, we know the resulting matrices then, from the dimensions, will actually be the number of rows in the first matrix by the number of columns in the second matrix. So in this case, where we have a 2 by 2, our final matrix ends up being as a 2 by 2 as well. So in this case, what you do to multiply is you take the first row of the first matrix, and you are actually what's called dotting it with the first column of the second matrix. And what happens is we take A1, multiply it by B1, so you can almost imagine that you are taking this row and flipping it vertically and matching up the entries. So we do A1 times B1, and we add to that A2 times B plus B3. Okay? And then once we've done the first column, the first row times the first column, we're going to move to the first row times the second column. So in that case, again, imagine you're flipping this vertically and matching up those entries. So A1 times B2, which is where we get that, and adding to that A2 times B4. Okay? And those are only our first two entries in the first row of our resultant matrix. Once you have gone through each row or each column in the second matrix with this first row, you then can move down to the second row. So now we're going to do the same thing. We're going to take this row, imagine you're flipping it vertically, and do A3 times B1 plus A4 times B3. And in the final entry, we'll move to the second column. We do A3 times B2 plus A4 times B4. And again, you would then calculate all these numbers, and that would give you your final matrix. Let's look at an example. So the example I've chosen, I'm multiplying a 2 by 2 matrix times a 2 by 3. Notice how these inner dimensions match up, which means we can do the multiplication. Our final matrix will be a 2 by 3, those outside dimensions. So let's begin. So for the first entry, we're going to look at the first column. Imagine we flip it vertically. We'll get 1 times 1, 1 times 1, plus 2 times 2. Again, matching that up. We'll move then to the second column for the next entry of our resultant matrix, and we get 1 times 3, and we're going to add to that 2 times 4. Again, this one and that one. And then moving to the final column, we get 1 times 5, and then we'll add to that 2 times 6. Once we finish with that row, we're going to apply the second row to each column in the second matrix. So we'll get 3 times 1 plus 4 times 2, 3 times 3 plus 4 times 4. And finally, moving to that third column, and the second row and third column, we get 3 times 5. And add to that 4 times 6. Okay. Now the hard work is done and we are ready to just do all these calculations. So real quickly, from this first entry we'll get 1 plus 4, which is 5. The second entry is 3 plus 8 to be 11. Then we get 5 plus 12 is 17. Moving down to the second row, we get 3 plus 8, which is 11 again. In this second entry here, we'll get 9 plus 16, which is 25. And then finally, we have 15 plus 24, which is 39. And there's your final answer. And again, all that matters is that these inside entries match. If you don't have that, you can't necessarily multiply the matrices. You also cannot always multiply, and this is very important to note, that a matrix A times B is not necessarily equal to B times A. And you would find that you can't even multiply these matrices in the opposite direction. And that's it. For more information, please visit our website at www.sandersonTestprep.com. The link is in the description box below. Thank you.